Hello everyone, welcome back to the class real-time systems. So in previous video we have discussed about the unit 1, that is basic introductions of real-time systems. So in that what is a real-time system, how it operates, what is the definitions, and what are the elements which is connected to that, and how the real-time systems are classified and what are the classifications are there. With an example we have studied about that introductions of the real-time systems. Now in this video we are going to start with the unit 2, that is concept of computer control. Okay, so in this concept of computer control we are going to talk about the introduction, and I have told you that in the beginning of the topic itself, the syllabus introduction itself. In this we are going to talk about the different computer controlling, because the real-time system if we are using, then it must be operate through the computer. Okay, so that computer, how it will be controlled. Okay, so the different types of controlling we are going to talk about in this unit. Okay, so the concept of computer control we are going to talk about basic introduction. What is a computer control? The basic introductions we are going to talk, and after that the sequence control, and then loop control, supervisory control, and centralized computer control, and historical systems. So these are the things we are going to talk about in this unit. Okay, and so when I come to this V2 point of view, examination point of view, so this entire topic can cover 18 marks. Okay, either of choice question you will get. So any one of the questions will come from this computer controlling unit. So this all the topics are important one. See, even the sequential control, loop control, supervisory control, everything which is important here. Okay, so we'll get into the topic. So the first one is the concept of computer control. So first we'll talk about the introduction. Okay, so in this introduction what we are going to talk is the computer, which is used in different ways for describing the various applications. So that will be used in wide variety of fields. Okay, so something which will be commonly, closely have the many of the common features. Okay, so the basic features of the computer control is considering the industrial process control. That could be classified as batch processing, continuous processing, and laboratory. The laboratory can also be called as testing. Okay, so the computer controlling application, the computer control which is mainly used in the industrial purpose. Okay, industrial process control. So that will be classified as batch and continuous and laboratory. So what is a batch processing? What do I mean by the batch? Okay, so the process in which a sequence of operations are carried out to produce the quantity of products is known as a batch process. Okay, so actually the term the batch is nothing but describe the process in which the sequence of operations are carried out to produce a quantity of batch. The quantity of a produce, and the sequence is repeated to produce the further batches. The same sequence which will be repeated until to produce the further batches. Okay, so the term the batch, which is nothing but which describes the process in which the sequence of operations are carried out to produce the quantity of producers. That means products, that means batches. So the same sequence will be repeated to produce the further batches. Okay, so the specifications of the product or exact composition may change between the different runs. Okay, so the composition may change one run to the another run. For example, in a steel rolling mill, the compositions of the ink guard may change, or the desired size thickness may be changed. Okay, see, for example, see, the same example I will explain in detail in steel rolling the mill. Okay, so we are considering this batch processing, right? So the batch processing is nothing but what? The group of products must be generated at the time. Okay, at the single time the group of products must be generated. Okay, so now we are going to consider the batch production in the rolling of sheet steel. Okay, so for that the ingot must be passed. Okay, so through the rolling mill to produce the particular gauge of steels. Okay. Next, that ingot can be either of a different composition or the rolled to a different thickness. If you see the steel rolling sheet, steel rolling sheet, the thickness may be changed. You will get a different thickness sheets in the market. Okay, so for that we have to give the composition may change, the specifications of that protections or the product may change. Okay, so it requires a different setting of the rolling mill. So if I want to generate a smaller thinner steel roll, then I need to give the thickness of that particular sheet must be raised less. So similarly, if I want to generate the thicker steel roll, then I have to give the thickness of the sheet must be larger. Okay, so like this how the specifications may be changed one batch to the another batch. But the batch processing is nothing but it generates the group of products. It generates the group of products, that is called the batch processing. And in this batch processing, the important measure is nothing but setup time. So what is the setup time? So the setup time is nothing but time taken to prepare the equipment for next production for a batch. Okay, so the time taken to prepare the equipments for next production of the batch. Okay, so it is wasted time in that no output is being produced. Wasted time is nothing but there is no output is being produced during that particular time. So the ratio of the operation time and then setup time is very much important in determining the suitable batch size. So to decide the batch size, we need a setup time and also a the operation time and also a setup time is very much important. Okay, and in the mechanical production, the introductions of NC, that is the numerical controlled machine tools, that has led to the shorter setup time. Okay, so the batch size, and one more thing I need to tell you here, the batch size. So the batch size, which is determined and defined by calculating the ratio between the operation time and also the setup time. Okay, so the operation time is nothing but what? The time during which the product is being produced, that is called the operation time. Okay, so the batch processing, that setup time and also your operation time is very much important here. Okay, so this is all about your batch system, batch processing. The next, continuous process. So the continuous process is nothing but the system in which the protection is maintained for long period of time. Okay, so the term continuous, which is used for a system in which the protection is maintained for long period of time without interruption. So that may be on several months or that may be on several years also. Okay, so for example, the cracking the crude oil. Okay, the ratio of the different fractions can be changed but without stopping the process. Okay, so the cracking the crude oil, the continuous system that may produces the batch in which the product composition can be changed from time to time. From time to time, the specifications may be changed. Okay, but while changing the composition, the production process is not stopped or halted as they are classified as continuous system. Okay. Okay, so we'll talk about in details about this cracking of the crude oil. In this cracking of the crude oil, in which enters one end, and then and the various products. Okay, so that various products, whatever which is there, the number of the particles which is there, that will be removed at the output as the process continues. So the ratio of the different fractions can be changed without halting the process. Okay, so the machine will not be stopped. Okay, whatever the process which is going on, it will not be stopped. So one by one we are taking the parameters or the products which is from that. Say for example, when we are doing the groceries, so the when we are generating, getting the products from the whatever the manufacturing which is performed. Okay, so the first product it may be on, for example, the first product it may be on wheat, and then last product is nothing but maida. So like this, how the quantity may change. I mean the quantity in that sense, the quality of the product may change. Okay, so for that we may change the specifications, but the system should not be altered here. Okay, so and the one of the disadvantages of this continuous process is that during the changeover from one specification to the next, in which the output of the plant is often not within the product tolerance, and that must be scrapped. Okay, and hence to resolve these kinds of problem, change should be made as quickly and smoothly as possible. So this is the solution for that particular problem. So the continuous product is nothing but it will be run in a continuous manner. The productions will not be stopped. It may be on the several months or several years. Okay, so this is all about your. So the next is the laboratory system. It is nothing but the frequently of the operator installed type in that the computer which is used to control some complex experimental test or some computer equipments used for routine testing. So for the routine testing, some kinds of laboratory systems are used. Okay, so for example, the blood sample testing and what is it? The medical checkups and medical equipments. So these and all the laboratory systems, lab equipments. So that will be used to control some of the complex experimental test. Okay, for example, control and analysis the data from the wafer phase of chromatography. So another example is the testing of an audiometer, a device used to test the hearing. Okay, it produces a sound level at the different frequencies. So this is tested using a computer. So the laboratory systems, by using that particular equipments, we are going to measure the values or the parameter what we are going to check. Okay, so that will be connected to the computer. By using that computer control, we are going to check the testing, whatever the testing we want to perform. So this is all about your laboratory systems. Okay, and the irrespective of this classification, the typical steps which includes data acquisition and sequence control, loop control, supervisory control and data analysis, and the data storage and human computer interfaces. Okay, and apart from this, the objectives of using this computer control, the process which includes what are the process: efficiency of operation, easy of operation, safety, improved products and reduction in waste and reduced environmental impacts, a reduction in the direct labor. So these are the objectives of this computer control. Now the first in this computer control, we are going to talk about the sequential control. So what do you mean by sequence control? By using one of the examples, we are going to talk about the sequence control. See, actually, generally the sequence control which occurs in the some part of the most system, it often predominant in the batch system, and also it is used for illustrations. So the batch processing which is used in this sequential control. So we are considering the batches are widely used and system which illustrate as follows. What are the things? So here we are going to take and before going to see this, the batch processing systems are widely used in food processing and also chemical industries, which involves mixing of the two raw materials, carrying out some process and then discharging the products. Okay, so now we are going to take one of the examples of the reactor vessel, chemical reactor vessel. Okay, so first of all, the chemical which is produced by the reactions of two other chemicals at a specified temperature. I will show how it will be done by using this diagram. If you see here, there are two chemicals. The chemical 1 and then chemical 2 here. So the two chemicals are mixed in a vessel with a specified temperature. We are going to produce a one more material. So that is the basic thing is here. Okay, so for this, okay, so this is the diagram which shows the chemical reactor vessel. Okay, so a chemical which is produced by the reactions of the two other chemicals at some specified temperature. Okay, so the two other chemicals, the chemical 1 and then chemical 2, which will be mixed and by setting the specific temperature. Okay, so the chemicals are mixed together in the sealed reactor, and the temperature of the reactor is controlled by feeding hot or the cold water through the water jacket which surrounded the reactor. See, if you can see here, there is a hot water and then cold water which is connected to the vessel. Okay, so the temperature if it is larger, then we need to reduce the temperature. So that will be reduced by applying the cold water. If it is on need to increase the temperature, or if it is on the temperature is a need to be maintained constant, then we can send the moderate, I mean the hot water to this vessel, so that we can control the temperature whether we can increase or decrease. Okay, so the two chemicals are mixed with a specified temperature, and that will be discharged at the specified time. Okay, after mixing those things with a specified temperature. So the temperature can be controlled by using these two valves. Those two valves are C and D. Okay, and so the water flows which is controlled by adjusting the valve C and D. So I have told you that no, the hot water and then cold water, the water flows are controlled by using this C and D valves. Okay, and the flow of the materials into and out of the reactor vessels, into and out of the reactor vessels, is regulated by the valve A, B and E. Okay, so this is E. So the chemical in which is through the valve A, and then chemical 2 is valve B, and the exit product, I mean the materials, whatever the reacted materials, so that will be come out from this valve E. Okay, so the temperature of the content of vessel and then pressure in the vessels are monitored always. Okay. Okay, so this is all about the diagram. Now I will tell you the procedure working of this system. So how this chemical reactor which works. Okay, so the first step is open the valve A to charge the vessel with the chemical 1. Okay, so the first step is opening the valve A to send the chemical 1 to the vessel, and second one, check the level of the chemicals in the vessel. If it is correct amount, then close the valve A. Okay, so the chemical reactions which will be fed into the vessel and checks whether if it reaches the specified level or not. If it reaches the specified level, the valve will be closed. And the third step is start stirring to mix. Okay, stirrers to mix the chemicals, and repeat the same steps, opening the valve A, and the step 2, I mean the checking the amount for this chemical 2 also, and open the valve B and send the chemical 2 and measure the values. If it reaches the specified amount, then close the valve B and repeat the and mix it well. So this is the operations. Okay, now all the two materials are chemical materials are fit into this vessel. Okay, now switch on the 3-term controller and set point. So what is the set point here? So this is the set point, 3-term controller and also a set point. So the controllers are the temperature controller here. The temperature will be controlled by using valve C and the valve D. Okay, and monitor the reaction temperature. So the reaction temperature should be monitored, and when the timer indicates that the reaction is complete, switch off the controller and open the valve C. Okay, open the valve C. So why we are opening the valve C? Because it is on cool water to cool down the materials whatever it is there. Okay, and switch off the stirrer. Okay, and after that we need to monitor the temperature, and then the content have been cooled, and open the valve E to remove the products from the reactor. Okay, so this is the procedure. Okay, so what is the procedure? It is one of the important question. Okay, you may get in your main exams, that is VTU examinations. So what are the steps here? first the step 1 is the chemical 1 must be fed into the vessel, okay, by opening the valve A and check the specified amount. If it is reaches the specified amount, close the valve A and start the stirrer to mix the chemicals. Similarly, fed the chemical 2 into the vessel and check the specified amount of value, and if it is reaches that, then close the valve B, okay, and start mixing, okay. And after that we need to set points and also a 3-term controller. So 3-term controller, and then temperature need to be monitored always, okay. After that, when the timer which indicates whether it is done or the chemical reactions are done, then open the valve C to fed the cool water, so to cool down the materials whatever it is there. Then once if it is done, and check the temperature. Once if it is check the temperature, and if it is cooled down, then open the valve E to exit the product, okay. So this is the procedure, chemical reactor procedure. So it is nothing but on batch processing. So the amount of the materials or products are generated at the same time, okay. So the group of materials are specified or produced at the same time, so it is called the batch processing system, okay. Now when I come to this so this okay, so this is the procedure whatever I have told, the same thing which is there, okay. And after that okay, so this is the diagram. I will tell you the typical chemical batch processing system. I will tell you the operations about this system, okay. In a large chemical plant process, the sequence becomes a very lengthy and also the lengthiest process, okay. So hence, in order to ensure the efficient operating and then several sequences to run parallelly, we are going for the computers, okay, to replace all the above actions whatever we have talked about in the previous, that will be replaced, and the timing based upon the software. So by using the computer control, we are going to produce a chemical vessel operation, okay. So the single chemical reactor, which is a part of the large process, which is shown in the figure, okay. So in previous figure we will be having the only one vessels, so that one vessel which is replaced by the two vessels here, the two reactors here, the two reactors namely R1 and R2, okay. Now so if you can see here, there are two raw materials, raw material A and then raw material B, which is there in this figure, and also the raw material weights and mix, which will be there in the next one, okay, and the reactor 1 and then reactor 2. So these raw materials are connected to the reactor 1 and also a reactor 2. Once if it is done, the reactor 1 and reactor 2 it's done, and it is come down to the washing and settling the tank, okay, setting the tank. If it is done, then another end which is goes to the thin down the tank, okay, and after that it's storaging of finished product, okay. So what is the thing is here? The thing is here, so there are two reactor vessels are used. So at a time, the only one reactor vessel which will be in the operation, the another vessel which will be in the washing process, I mean it is cleaning process, under the cleaning process and setting the tanks and all, okay. So the both will be works in parallel, okay. Once if it is the reactor 1 is done, then reactor 1 will be under the washing process and reactor 2 will be in the processing, okay. So now the raw material 1 and raw material 2, so these are the chemicals, so chemical 1 and chemical 2 which will be sent into the raw material weights and mix, okay. Some amount of the raw materials are sent here, so here it will be check the weights of the raw material 1 and raw material 2, that is A and B here, which according to this figure which is given, okay. Once the weights and all done, it will be mixed properly, then that will be sent to the reactor R1. So during this time, the reactor R2 will be in the control of cleaning, okay, washing the process, cleaning the tank, okay, vessels. Now so the reactor 1 which will be in the process, okay, within the temperature, I mean with the fixed temperature, it will be under the processing, okay. once if it is done, so then that product will be sent into the thin down tank. Okay, so after this the raw material C which will be sent. So here the to cool down the process or whatever it is, so that will be performed and that will be sent to the storage of the finished product. So once if it is done, this reactor R1 which will be under the cleaning process. Now at the same time the second batch of the raw materials are ready and that will be sent to the reactor 2. So that at the same time the reactor 2 is ready for the process. Okay, so this will be performing the operation and this reactor R1 will be in the cleaning process. So the same process will be performed parallelly which performs. So this is all about here the typical chemical batch process under the controlling of computer. Okay, so the group of batches are generated at the same time here. So instead of that manual operation, when it is on computer control, so everything which will be controlled by the computer. Okay, so when the sequence of the operations becomes more complex, then we have to take a complex decision to begin the sequence. Okay, so that complex decisions can be initiated either by the human operation or maybe the computer programmed to supervise the operations, right? So this is all about your sequence control. Okay, so here the everything whatever I have told, everything which is there. Okay, so these are my references. According to the video examination, this question is important one. Please go through this question. So they will be asking about write the short notes and explain the following. One of the thing is the supervisory control system. Supervisory control system. Okay, so this is for 10 mark question, and one more the question is the batch processing and continuous processor, both which is for 10 mark question. Okay, so this question is important. For that you have to write what is the supervisory control and the manual process you have to explain and the computer control you have to explain. Okay, so you may get this question is for 6 to 8 mark question, the minimum. Okay, and one more question paper. Explain the sequence control by taking the examples of simple chemical reactor vessel. Shown the block diagram of typical chemical batch processing system. So it is a 10 mark question. Okay, and in one more year. Okay, so the 2 times this question which appears in the video examination in earlier years. So this is the one of the important question. Okay, and these are the references. I hope this video is helpful for you. We'll meet you in the next video. Thank you all.